Okay, so we're going to be taking a look at graphing our quadratics in standard form. That means that we're going to be looking at these and instead of converting them into vertex form, we're going to actually figure out another way to graph them. The quickest way to do that is going to be to find our A value, our B value, and our C value from the quadratic. That is when we're looking at standard form, we have ax squared plus bx plus c. So in this particular example for number 1, the a value is equal to the number 1, the b value is equal to -4, and the c value is equal to 7. So those are the numbers that I want to make sure that I'm using as I go through. Next, I'm going to go on and find, the first thing I'm going to find is the axis of symmetry. And the way we can find the axis of symmetry is it is the line where x equals -b over 2 times a. So I'm going to use these numbers to figure that out. So -b over 2 times a. So that means that in this particular example, it's -4 over 2 times 1. I'm going to simplify this, and that becomes 4 over 2. So it's the line where x equals 2. So I have my axis of symmetry. All right, the axis of symmetry, you may recall, is the line that goes through the vertex point. It's the reflection line for the quadratic, and we just found that it's this line right here. Now I'm going to take that number and use it to find the vertex, because I know that my vertex point falls on the axis of symmetry, so that means that the x value for my vertex is 2. So I know that the first coordinate for my vertex point is 2. The only thing I need to do in order to find the y is to plug this into my original equation and find the y. So I'm going to plug it in, replacing the x's. So I know that y is going to equal, it'll be 2 squared minus 4 times 2 plus 7. All right, so 2 squared is 4. -4 times 2 is -8, and then plus 7. So 4 minus 8 is -4. Plus 7 makes this equal to the number 3. So my vertex point is 2, 3. All right, so I'm at 2, 3. Here's the vertex point. That's the vertex. We know that to find the y-intercept, the value of x is always 0. So you're going to just plug in 0 into your equation to replace the x and find the y. So that would be 0 squared minus 4 times 0 plus 7. Zeroes out these two terms, so our answer is just going to be 7. So our y-intercept is the point 0, 7. So that's going to be here, 0, 7. Next, I need to find the reflection of the y-intercept. Now you may recall that this is equidistant. My y-intercept point is equidistant to its reflection point on the other side of the axis of symmetry. So if this is 2 units away from the axis of symmetry, then its reflection is going to be 2 units to the other side over here. And that happens to be 4, 7. So 4, 7. Now I'm ready to just graph my quadratic through these given points, and I have everything labeled, and I'm done.